Hi, I'm Bruce, and welcome to my Baptronics Mountain Labs. And today we're taking a look at the second of my B&K Precision 1856 1.3 gigahertz frequency counters. And we're going to walk this one through its paces just to kind of see how we're functioning across the spectrum. Um, let's take a look at it first. The unit is in exceptionally good shape. It's like minimal or no scratches in the case whatsoever. Handle is intact. Feet, underside, everything looks great. Let's get a look at the back side. And we have serial number 222-00083. You've got line voltage select and a Totalize start-stop input on the back, as well as the power cord and fuse. So, and on the front panel, let's see if we can catch a little glare here so you can see. No scratches on the plate or on the glass. Very nice. Okay. Well, we've just completed adjusting the TCXO for this B&K Precision 1856. We've got 10 million hertz coming in from our master oscillator up top side there with the tube sticking out of it, the silver plate. It's been calibrated to a rubidium, and I know that she's accurate to better than 1/10 of a hertz. So this one here is, we're reading 10 million right on the nose in the 1 second interval. We'll go to a 10-second interval and pick up another decade of resolution and see what we got here. Okay, so we just did it, and it looks like we are dead on at 1/10 of a hertz, so we're better than 1/10 of a hertz at 10 million. Now this is in a room that's 68 degrees Fahrenheit, and we've been running now for about 4 hours today, so she's about as warm as it's going to get. And so if your room is 68 degrees and you let this thing, stay on for a couple hours, then it looks like we just picked up a fraction of we got 1/10 right now. That'll probably go away the next cycle, but anyway, there it just did. So you'll be able to duplicate it with any luck at all. So anyway, let's move on with our testing on the unit. We're bringing in a signal right now from my PTS 500. Let's put this thing up at 100 megahertz. This would be the input A maximum signal. All right, we have 100 megahertz coming in on channel A, and we see that we're flashing 99,999,999 to 100 million. Let's take her down to 5 hertz. That's the minimum signal. In order to do that, I've got to switch my input. We switch to our HP3320B. We're taking the output from it. We're running a 5 hertz signal. That 5 hertz signal is coming in on channel A. We're in the kilohertz mode, and we are reading 005. No problem. And if we wanted, we could pick up an extra decimal place by expanding our time base to 10 seconds. And there we go, 0050. No problem. Okay, so let's switch to the input on B. we've just spanned the entire frequency range for channel A. Alright, at this point we want to switch to channel B, and we are going back on our PTS 500. PTS 500, channel B, we're supposed to go 80 megahertz to 1.3 gigahertz. So we're going to go 80 megahertz up here. 80 megahertz. And there we go, we got 80 megahertz. Okay, in order to go to the anywhere near 1.3 gigahertz, I'm going to switch to my HP8640B. I've got an external doubler on here, and I'm in the doubler range between 512 and 1024. So everything you see on that meter face is double what's actually coming out of the unit, and will match what's coming out of the doubler. So right now we've got 512 megahertz showing on the dial, and we've got 511.9998 on the counter, give or take a digit. Okay, so now we're going to go ahead and run ourselves up to the far end. 700, 800, 900 gigahertz. 1.09967 is what I'm showing on the dial here. And we are reading, it would be 1.0996693, so 9967 would be right. So in beautiful form, it's gone the entire range of 80 megahertz to at least 1.1 gigahertz, no problem. Well, to demonstrate period, I've gone to the HP3320 again. It's my low frequency generator. We're at the 5 hertz signal, and primarily you're interested in measuring period in the low ranges generally, because you'll get much more resolution in low frequency. 5 hertz showed up as, at the very best, under a 10-second condition, showed up as 0.0050, and that's after 10 seconds. It was 0.005, so you had 1 digit of resolution at 5 hertz. However, if you go to period mode, you'll see that you get about 200,000 microseconds, give or take a few microseconds. So we've picked up 1, 2, 3, 4, 5, 6, 7, about 7 decades of resolution that we didn't have otherwise. So even if you used only the first few, you can see that you're going to wind up with a much greater resolution and accuracy in the period mode than in the frequency. Let's go ahead and take ourselves up in frequency. There's 100 kilohertz. And at 100 kilohertz, at least on this range, I'm picking up 10 microseconds. Okay, so we're at 1 megahertz. 1 megahertz on the HP3320. And we're reading 1 microsecond. No, we're not. We're reading 1. Yeah. Okay, that's better. And we're reading 1.00 microseconds on the 0.1 second gate time. If I go to 1 second gate time, we pick up another 0. So it's saying 1 microsecond, so we've got a 1 megahertz signal. That would be right. 100 kilohertz, we've got 10 microseconds. 10 kilohertz, we got 100 microseconds. 1 kilohertz, we've got 1,000 microseconds. So the period is reading just fine. Let's take a look at the Totalize. Let's go to something that's slow enough to see. Right now I'm feeding in a 1 hertz pulse. And if I was to reset 1, 2, 3, 4, you can see we're counting, we're totalizing. And if I was going at a much faster rate, maybe something I couldn't even otherwise see, here we're reading at 1 kilohertz rate, picking up 1,000 hertz every second. Now, there is an input on the back of the unit I showed you earlier, and you can put a start and stop signal, TTL-wise, on there, and it will control this counter. So you can count incoming pulses over a start and stop period. There's also a check function on this unit, and you punch check and you can change the number of digits you want to display, give yourself some resolution here, but basically we're checking the 10 megahertz time base inside, and then we're looking at all the counter circuits and displays and so on, and trying to display the internal count to 10 million. So if you see it, then you know that majority of your machine has checked out just fine. So there we have it, a little test on the unit. It looks very nice, passed on flying colors. This unit will also come with a user guide that goes to a BK1856. It was a C. The two of them look the same. They have all the same functions. The difference is that the C goes up to 2.4 gigahertz. This one's 1.3. However, I also have for this unit the circuit diagram and parts list for this unit alone. So specifically for this unit. And that'll come along with it, as will a power cord, so that you can get this thing going right away. So thank you for listening, happy bidding, and we'll see you again.